In problem 3.33, we have a sailboat going horizontally with a velocity of 6.5 meters per second. So it's only going in the x direction. And then for a period of 6.3 seconds, let me check to make sure that's right. Yes, we have an acceleration of 0.48 meters per second square at an angle of 35 degrees. So we have a wind gust that's going to change our direction. So we're going horizontally, but our acceleration is up and to the right. Now this is not an acceleration of gravity kind of problem. This is just a horizontal x, y. There is no z direction that we're considering here. So we have a gust of wind that's and an acceleration, let's say up and to the right relative to, say, a helicopter view here. We're looking for the distance traveled over this period of time, 6.3 seconds. So from the time that the wind gust stops to the time that we reach a period of 6.3 seconds, we want to figure out how far it traveled. I'm representing that with the unknown r, and that is going to be simply the x distance that we travel squared plus the y direction that we travel, so up and to the right over here, square root. That will give us the total distance traveled. Since we have a constant acceleration given in the problem up here, there's no time dependence, we can use this equation to find x. So x equals x naught plus v naught xt plus 1/2 at squared. The only thing we want to pay attention to here is that there is no cosine of the angle right here, but there is one over here. Well, why would that be? The reason why is that the velocity is given to us and it's all horizontal, so there's no reason to do a cosine or anything like that. However, the magnitude of the acceleration is magnitude of the acceleration is 0.48, the direction is 35, so for the initial velocity, I simply take the initial velocity times time. However, for the ax, I have to find the magnitude times the cosine of the angle. So this is 1/2, and all of this is ax, and it's times time. So this is not an acceleration for projectile motion. In those cases, we had acceleration equals 0. We have a horizontal problem, so the acceleration is magnitude times cosine of the angle. We do the same thing for the y direction, and realizing that this is 0, why is v naught y 0? Well, again, because our velocity is only horizontal, so there's no direction. There's no velocity initially in the y direction. So we do the 1/2 times the acceleration times the sine. So this right here, all of this is ay, and then there's the time. Doing all the mathematics here, all the algebra, making sure all the units work out, we should get a distance of meters. I just realized I made a mistake up here. I have meters per second. In second, that's going to give me meters here. But here I just have 1 second, and this right here is going to give me meters per second. So that cannot be, because this is a unit of distance. So I got to remember that the square is here, so don't forget the square when we do 6.3 seconds. And also the same is true for this one, 6.3 seconds square. All of this then gives me a unit of meters. I can then take the square root of x squared plus y squared to get the total distance traveled during the wind gust for this problem.